Welcome to this webinar this morning, organised by Theben UK and being delivered by the fantastic team at Hagelock at the Theben HQ in Germany. So we're going to be talking about room control, looking at all aspects of room control, so the environment, lighting, heating, ventilation, all those areas, and how we bring those together to create the perfect environment to live and to work in. Excuse me. As it says, it's Elmar Loeffler that's going to be giving the presentation, supported by Christoph. So just a sort of few technical things. If you've got questions, please do put them in the chat box during the talk, and hopefully Christoph will deal with those. And we'll also have a quick Q&A at the end of the session. So what I would like to do is thank MyKNXStore in UK for supporting us on this webinar today. MyKNXStore have been around in UK supplying KNX for a number of years and are one of the key UK suppliers and distributors of KNX material and other material as well via their parent Park Electrical. Unfortunately, the guys can't be with us today because they've got an internet problem, but I think they're looking in. So morning to you guys. I hope you get the internet sorted out soon. One of the things about MyKNXStore is that they're not just a wholesaler distributor. These guys can support you through your KNX project from design through to supply and through to support as well. That's the key thing. They know the Theben product and they know how to support it. So thanks again for enabling this presentation today, the guys at MyKNXStore. Okay, that's enough from me. I'm going to hand you over to Elmar, the very, very capable hands of Elmar, who's going to take you through this webinar. Thanks, Elmar, and over to you.
Thanks so much for the warm welcome this morning. Hi, a few words to us. So Christopher, who has assisted me the last couple of days in preparation of this webinar today, is in the dashboard. So that means if you have any, let's say, questions during the webinar, however, so please post it in the chat box and Christopher will give you the reasonable replies. From my part, to my person, I have to say I'm responsible for technical support and training. So and during this special year, I have to say, we are giving lots of national and international webinars, and so we are really happy to support you today. I think we will have an interesting webinar, so heading us for about 45 to 50 minutes. And it's, let's say, we have two parts. One part is, okay, first a little bit theory, okay, required. And the second part is finally, that's the reason why we have here, let's say, some equipment. I will do some practicable parts. So that means to show how the real work finally is. So let's start with these, let's say, details here. So all these, let's say, new buildings, school offices, buildings, public buildings, however, so the requirements for such buildings are finally the maximum of automation in order to get the most energy efficiency, well-being for the people working or living inside as well, so and comfort. And all these buildings finally are designed international standards like LEED, BREEAM, GBI, or European norm 15232 in regards of energy efficiency. And when we have, first of all, a glance on this is the EN 15232, but all these, let's say, LEED, GBI, BREEAM, and so on, so the content finally is pretty much similar to it. So when it comes to the heating control, so it is in general a single room control, but communication with, let's say, intelligent management system control on demand. So just if somebody is in the room, using the room, is present in the room, so then the heating and the cooling should be activated. The air condition, air quality control is meanwhile a big part of these public buildings, of offices, schools, and so on. You know, if you have a good CO2 quality, a good air quality inside of the building, the people are more attentive. Yeah, we will see later on a little bit more about that. When it comes to the illumination, so illumination, so there are two approaches finally: to switch on off lights or to do daylight control or constant light control. So light control according to the natural daylight. So this is the high efficient and the most comfortable way to illuminate a room. Nevertheless, if you control this by universal dimming or by a Dolly gateway, nevertheless, but the solution finally around is the essential one. And when it comes to the sun protection, so especially in these, let's say school offices, public buildings, and so on, so you can do, let's say, shading according just to brightness. So when the threshold is exceeded, so then, for instance, shading starts. But the highest efficient is finally if you have a shading control, which supports you with sun tracking. Later on, you will hear some more. So, and this content is nevertheless a part of GBI, a part of LEED, a part of EN 50232 or further on. The approach finally, when it comes, for instance, to the shading control. So sun tracking, most best, highest efficient. Advantages finally, comfort, energy efficient, and some of the shading control, especially the actuators, are smart enough to support heating or cooling. Yeah, we have here pretty less settings in our application setting to give you these reasonable support, these high energy efficient. This just acts on presence, for instance. So when the sun rises, you can see here. So sun rises early morning, so the sun is coming in quite flat. So we have here the blinds totally closed, so to avoid that we have dazzling inside, for instance. So then the sun is rising more and more, so comes higher in the elevation. So then the slats open with the sun. So what is the purpose of it? It is finally the purpose that you get as soon and as much daylight inside in the room as possible. Why? Because inside in the room, you have to illuminate the room, isn't it? And as much daylight you get, as less artificial light you need. So slats turn according to the sun positioning, which is called sun tracking. So then it comes to the illumination finally. Illumination means constant light control. If you have ever had the chance to work under conditions of a constant light control, for instance, you will love it because it is most comfortable illumination which you can get. At the same, nevertheless, early morning, midday, or in the noontime or in the afternoon, however, you have any time, you have the same brightness on your working spaces. And this is for your eyes, for your concentration to your work, most comfortable. And in regard of energy efficiency, the highest degree of it. Yeah. Anytime you can, let's say, modify the current brightness. So probably if you need a little bit more light, however, anytime you can override, by manual operation, by push button or whatever. And in terms of the energy efficiency, in terms of climatization. So here, I'm talking today about the fan coil actuator. So because in most of the public buildings, of the school buildings, of industry areas, offices, however, so then we talk in general about fan coil. So that means heating and cooling. So for the different seasons, you have the right, let's say, a source, heating or cooling source, in order to get the right temperature in your buildings, in your offices. However, So for this purpose, you need an RTR, a room temperature controller. Okay, it could be, for instance, our Eon, which is one of the newest products joining our product range. And what's the advantage of these fan coil actuators? So the fan coil actuators finally gives you both values for the heating control and as well for the cooling control. Yeah, we need just a set point, a set temperature from the room. Air quality, it's important meanwhile, especially in public buildings, and not just in terms of, let's say, carbon dioxide level. Yeah, like I mentioned, as good the air quality finally is in the room, as more concentrated you are, as more comfortable, for instance, you feel. Currently, as well, the dehumidifying plays a big role as well for the well-being. So that means the degree of CO2 and the degree of humidity inside of the room is essentially for your feeling, for your well-being. And this you can control with a fan coil actuator. And what if you put all this together in one room? So that means you integrate, you collaborate all these functions, and the result finally could end up in the smart room or the clever room, however. So a little bit more detailed now. So that means we just concentrate a little bit on the, let's say, part of the heating. We need a room temperature control, sure. In our case, we take the ion, the room controller, then a heating actuator or a fan coil actuator, however, in order to drive a valve. So this is standard. But for this purpose, you have to use heating, or have to support heating and a separate cooling actuator to open the separate, let's say, valve. Due to that, we recommend to use the fan coil actuator. So this is just another example, the heating actuator for the floor heating, but you need a separate one. And if you want to do all in one, so then take please the fan coil actuator. And the fan coil actuator is able to give you three options finally to monitor, to moderate finally the heating, and as well to do the airing control, yeah, in steps, 3 steps, or stepless, 0 to 10 volt output commands. For instance, to control dampers, yeah, in big airing systems or climatization systems, however. So this could be quite interesting, especially the stepless 1 to 10 volt control. So this means assisted by a clever, let's say, shading control, which requires for the sun tracking, the weather station, which in our case is Meteodata 140S, smart enough, clever enough to know when the sun sets, when the sun rises, due to the local geo positions, for instance. And then you can address from the weather station, so which facade of the building shall start with the shading, which position we should have on the easterly side, which later on, which position of the shades we should have in the southerly side and further on. And the weather station is smart enough to give you the reasonable, let's say, values of the repositioning when the elevation of the sun changes during the day. As higher the sun comes finally, as more open the slats finally get. In our case, in our example today, we are using the JU1, so the small, tiny little shutters blinds actuator for this demonstration. And as well, we need the daylight control. Yeah, so in the daylight control, which products are essentially, which are required. So you need a powerful presence sensor. And what is the precondition for the presence sensor? The presence sensor has to have a permanent light metering. So anytime, every second, the brightness, the brightness sensor inside of the presence sensor should be update himself. How is the condition here on the table, for instance? If we have some clouds, so the condition here on the table changes, the sensor on the ceiling has to realize or recognize finally, and to send the control commands, the dimming control commands accordingly, to dim a few bit up, to dim a few bit down. So this is an automatism you have to care about. If you do the setup once, you need exactly 4 group addresses, and then the system runs. Nevertheless, if we talk about here the universal dimmer, so as an example, for instance, the D2T, DM2T, for instance, or if you do, let's say, these light control with a dolly gateway. So you have implemented, in this case, for instance, 64 lights. You do some groupings of different lights for several areas, however, and then you can do the dim, the constant light control accordingly. Full automized, so that means you have not to do anything about. But as well, you can anytime press on a push button and you override, you need more light, there is more light required, or probably for school purposes, for instance, the teacher or the professor wants to show some video or whatnot. And so probably you have to reduce the indoor light recently. And so that means, so you at any time, you have the chance to reduce or to manipulate or just however you like or you need it. So, and what if you merge all these together? And this makes finally the smart and the clever room. So, and this sounds really complicated. Yeah, so first of all, it's really sophisticated to do the temperature control, the shading control, the presence, and so on. And further on, it sounds really complicated. But what you get, so what is the reason why we put all these, for instance, together? Let's give you, or let's share some ideas with you together. So that means if we want to have heating support due to shading control, so according to the brightness threshold, the blinds remain open. Why this? So let's do an example. So the indoor temperature, for instance, early morning is probably 18 degrees, so not that much. So nobody is in the room, but the sun was rising, and we have now a pretty warm and a pretty good summer day, however. And the threshold is met, the condition is met. So then in general, the blinds run down and close to give you the reasonable, let's say, sun protection. This is standard. So, but what is the intention? What is the idea of this solution? So nobody present in the room. The temperature indoor is below the set temperature. Outdoor, we have a nice sunshine, we have a nice day. So what happens? So the sun will give you energy, warmth energy for free through the windows. Supports us to heat up the room, isn't it? So, but what if somebody enters the room by a presence detector detected? So what happens then? So finally, then the system realizes, okay, now there is a meeting probably starting or a lesson starting in the school, however. And now the blinds run down and open their slats according to the sun positioning. So then the sun tracking starts. So you have a maximum of energy gains as long as nobody is in the room. Somebody enters, then you have full sun protection, no dazzling. And the slats are adjusting accordingly during the day. If you leave the room, then it depends finally how the condition is. Meanwhile, if the condition is met, the room temperature inside is like the set temperature, for instance. So then the blinds could, it's a matter of how you have adjusted it. Finally, in the ETS, they will adjust during the day, or they keep still in their position, however, or they rise if, for instance, there is no sun protection needed anymore because the sun turns from the easterly side now to the southerly side and so on. So you can rise the blinds on the easterly side. So that's a matter of the settings in the ETS, but nevertheless, you leave the room and then the blinds will position themselves accordingly. If you have a CO2 value, which is rising during that time of meeting or of the lesson, however. So what happens automatically? So the CO2 value, when the condition is met, the threshold, First level probably is about 800 ppm. So ppm stands for parts per million. It's like lux for the brightness. So ppm is the value for CO2, or for instance, humidity in percentage. So and as long as somebody is present in the room, as well, there is an automatism kicked on. Yeah. So if the CO2 level is too high, so then the air circulation starts automatically in stages or stepless, for instance, due to 0 to 10 volt commands, output commands, for instance. So that's the heating support. So, and what if, for instance, if we talk about the cooling support? So we have pretty much sun, we have warm days like we had here in the last couple of days here in Germany, 35, 36 plus. So amazing warm. So and what we need here, we need cooling support. So basically, if in such rooms there are climatized rooms, so supported by a huge system, cooling system, for instance. So what if early morning the sun is shining brightly, so the blinds automatically run down. So this start of this procedure could be given either by a bit command, by a push button, so you can start it manually, sorry, or you have time management in the background, which gives, let's say, the on command, so operate now, enable now, and this sun shading control. So early morning, sun is shining brightly. So and then automatically, nobody's in the room, but the blinds run down immediately. Full closed, so that means full protection of the infrared light of the sun. If somebody pops in for the lesson, for a meeting, whatever, so and then just the slats open on that position, which is calculated from the weather station, and they open the slats according to the elevation of the sun. So you get now maximum of natural daylight inside of the room. Yeah, so that means the artificial light controlled by a Dali gateway or universal dimmer, however, can slowly, softly dim down, because as brighter it becomes outside, as more light you get inside, and so you can reduce as well the consumption of the energy which is required for the light. Finally, the maximum position is 90 degrees, so that means the slats are flat, 90 degrees position, so you get maximum daylight inside into the room, and so the constant light control can dim down or switch off, depends. So that means you have maximum of Daselman and a maximum of, let's say, internal light control and energy efficiency. However, due to the CO2 values or humidity I described, it's the same approach like in the heating support, however. And when people or students are leaving the room finally, so then the presence sensor discovers, okay, nobody there anymore, lamella, close 100%, and give you again shading protection. Yeah, so that the system, the cooling system, gets support from the blinds automatically. You have not to do anything. Yeah, this is an automatism which runs on his own. I think really impressive and pretty simple. And again, you probably expect now this is rather complicated to do the setup, to do the allocations, to the group addressings, and so on. I will allow you a glance behind the curtain finally. So you see here, we have here, this is an RTR, room temperature controller, could be Varia, could be our Eon. So you need just to give, let's say, the heating value, the heating to the heating valve or to the FCA. However, you need this as well for the cooling support. So this is just one group address of the object 13 to the object 0 of the FCA2, object 16 of the Varia to the cooling object of the FCA2. Then you need, for instance, the activating value, which you have to send to the shading control, because we have here in our switching, not switching blinds actuator, we have here a communication object which requires how is the situation in the room, yeah, And according to this situation, the smart blinds actuator discovers now if he has to support us with cooling support in the action, so that means down and closed, or if the room condition is not met, and then he release the shading in the upper position in order to support us with the maximal daylight and with the sun, which supports us to heat up the room accordingly. So what we have here next, for instance, we have here the forced mode. So this is just required for the airing system, for instance, so that this airing system finally starts. Then we have to link the presence to the TEPREMA, because TEPREMA gives the VARIA the information. So what is ongoing, somebody present, yes or no. And as well, the shutters and blinds actuator needs this action as well, this information, this update. Okay, somebody there or not, yeah. And accordingly, the blinds will run up or will run down and close accordingly. The fan stage is just to be linked on the group address 8 of the FCA2. So because why it's linked to the room controller, it's linked to that because anytime you have the option to operate manually. So if you want to do, let's say, a forced command, you want to get, let's say, in a shorter time, the air exchange, for instance, anytime you can modify this as well. Or, and that's the reason why we have here the link to the ventilation as well. So if the CO2 sensor, which is here on my board, so if the sensor discovers, okay, the humidity is rather high due to this high humidity we have currently outside, for instance, so then the automatism starts automatically. So please run step 2, 1, 2, 3, 4, or give the value 0 to 10 volt to a stepless dumper or stepless fan control, however. So when it comes to what has to be linked finally from the weather station, and I assume you discovered now that the meteor data, the weather station, is has to be quite smart, yeah, because according to the geo position, so longitude, latitude, and finally the time zone, and finally the positioning of the building, for instance, the weather station has to be smart enough to give the reasonable values for the sled's position. So the weather station has to know, so at which date, which elevation, and which azimuth finally the sun is running in this area where the weather station is used in. So what has to be linked? And probably you will be astonished. It has just to be linked the up and down command from the weather station to the shutters and blinds actuator. We need the height command. So that means this is just to drive to the specific position, which you can adjust in the drive settings finally. And the most important finally is this as well. So you need to link the percentage value of the lamella coming from the weather station to the shutters and blinds actuator. And this is exactly the value which is required to adjust to do this automatically. And anytime, and that's the reason why I linked these group addresses here as well to the room temperature controller, VARIA or the EON, for instance. So we need to override, or we have the option finally to override up down, or for instance, we can do step stop control if you want to override manually. Yeah, so this is the option. When it comes to the dimming, so the dimming, so this is just again linked to the room temperature controller or to the display. Anytime you can override the dimming. So you need on off, you need brighter darker, you need the feedback and the dimming value. I discovered now a little mistake because I haven't translated here these communication objects, but due to that I tried to describe it with words. So you see this brighter darker. By the way, you learn now German. Heller dunkler means brighter darker. So that means this one is linked to the heller dunkler, to the brighter darker of the presence sensor. So this is important to receive the command from the presence sensor to the dimmer, please dim up or please dim down. And the same communication has to be linked as well. This is just an option if you intend to control this with the dolly gateway. Yeah, so the control commands are the same. The communication object or the naming of the communication objects are absolutely equivalent. Yeah, so due to that, it's just the option here if you intend to go for universal dimming, or if you intend to go for or to decide for a dolly gateway, the communication objects are same. What we need the feedback object. Feedback object is important finally. So if the presence sensor discovers, okay, it's too dark, so please dimmer rise a little bit. So and this value has to be sent, and here is a communication ongoing. So the dimmer has to give a feedback on these communication objects here, on this communication object 3. So I am currently at, let's assume, 62%, and the TEPREMA compares it finally to the reasonable situation on the table and decides, okay, he has to send a value again because the condition is not met, so please rise further on. And when the condition is met, so then the TEPREMA sends a stop telegram, and so the constant light control stops immediately. If we have the other way around, it becomes darker, however, so because there's a cloudy day, thunder is upcoming, however, so then the TEPREMA, the presence sensor, starts again to send on the communication object 3 a value telling the dimmer, so please rise your dimming value currently a little bit because I have to bring this all again into harmony because there is some, let's say, artificial light required. So pretty simple, and a few less group addresses are required for such a sophisticated and in terms of energy efficiency, the highest degree in a room. So you see here a table of truth, which tells you a little bit. For instance, the current temperature is 18 degrees, nobody there, heating support is required, and for instance, adjusted, the blinds are in an upper position. The temperature inside in a room, for instance, there is nobody there, heating support is not required. Okay, the yes has to be here. So then you can run, for instance, on a specific position. So preset 2, you can adjust, for instance, special conditions before. So if it comes to the cooling, 24 degrees is the internal temperature, for instance, nobody there, heating support is not required, but cooling support, yes. So then drive down, lower end, close the blinds totally. And depends on that. So you have a full automized system. The effect, to make it a little bit more, slightly a little bit more precise. So these, let's say, sun tracking. Here is an example just of a single family home. We have here a 4-channel switching actuator. So the sun is rising on that side. So that means this sophisticated solution, this sun tracking, starts on the easterly side. The flaps, the slats are adjusting accordingly. Then the sun is moving around the building. So this is the azimuth. So runs around or moves around the building, for instance. Then channel 2 starts here to give you the reasonable shading when the sun comes on the late noontime. So then it starts here, and finally it ends up with the channel 4 on the easterly, on the westerly side, where the sun finally sets. And depending on this elevation here, on the positioning during the year, so the slats are opening and following exactly this move of the sun day by day. And that's, again, that's the approach. You come in, so the artificial light turns on and the sun is rising a little bit, so the slats are moving accordingly, and so you have the maximum of the natural daylight, and you can start to dim down this automatism. And this is, I think, quite interesting. So in regards of the application settings, so I take here, for instance, the application settings of a shutters and blinds actuator. So we need, for instance, the kind of the motor should be, for instance, an electromechanical motor, and this has to be linked finally to heating and to cooling support. The same settings, not the same, but similar settings for the maximum of the energy efficiency. You can use, for instance, these, how it's called. It is the highest activating value. This could come, for instance, from floor heating. This could come from ventilation, for instance. And you can, if you have a smart solution, a smart heating solution, which is, for instance, communicating an open term base. So then you can plus act on the heating curve. So if there is a big demand, automatically you can rise the heating curve. If there is no demand for heating, so you can lower the heating curve automatically. So this you can do or execute finally by the open term gateway, by the heating gateway from our product. I have not considered this in this presentation, but this could be an additional plus, for instance, to have the highest degree of the energy efficiency. FCA1, heating cooling support plus ventilation, step 1, step 2, and 3. And here we have the FCA2, looks totally similar. So the same housing, a difference is here in the printing, okay, FCA1, FCA2. And the most important thing is finally the output. And the output is giving you here a 0 to 10 volt control command in order to give the stepless control. Short step into the CO2, let's say, control. I think this is something which we should consider more and more in this example, for instance, school rooms and so on. We have to bring in a good value and a good amount of fresh air, because as you can read here, 30 children during the day needs about roughly 750 cubic meters of fresh air during the entire day. Depends on the size of the room and so on. So these values I got from the Association of the HVAC manufacturers. And the average, what they are giving into the room from their body heat is approximately 2.5 kV. So, and depends on the humidity outside as well, approximately 1.5 kilos of steam humidity, and approximately 500 liters of exhausted 5 liters of CO2. So that means there is a big impact of a certain amount of people in a room, which requires finally a certain, let's say, reasonable good ventilation. So there are different approaches. Finally, when it comes to the ventilation in general, you can do a ventilation, for instance, according to, let's say, a time control, a time management system. So every hour for 10 minutes, for instance, the ventilation is running. Okay, fine, everything is well. But what if nobody there? Is there any need? The ventilation costs electrical energy. And consider, for instance, when we have autumn or winter time, we have cold air outside. We need heat to heat up our rooms, our environment inside. So that means warm air is exchanged, is blown out to the outside of the to the ambience, and with the fresh air which we are hoovering in has to heat it up again. And due to this, let's say, presence dependent presence dependent CO2 values, or presence sensor, like the Amun here, for instance, is doing. So this is a kind of independent referee. So that means the sensor discovers how is the air quality. Yeah, nobody there, so the air quality is there are no reasonable changes. Why should? So if people are coming in, class, a lesson starts, or at the university, the professor is holding his lesson, however. So a bunch of students are coming in, and so automatically the CO2 value is rising, the sensor is discovering this and drives accordingly, finally, the air ventilation or the dehumidifying. Yeah, and this is an automatism running on his own. There is nothing to do. especially. But I think one thing you need to know finally to get a little feeling about that. So breathing in a good environmental circumstance, for instance. So when you go for hiking or just out in the environment, however, so in general, we have good air, and the air quality is approximately, depends on where we are, so 400, between 400 and 600 ppm, so parts per million. But due to the natural human breathing, the exhale depends on the physical strain finally, can be up to 40,000 ppm. Okay, any questions? So that means we have here a certain factor which has a certain impact on the air quality inside of the room. We are talking about CO2. Okay, so for a reasonable, let's say good light control, we need the presence sensor. So T-Prima, for instance, the Prima P is this one here, or the Tironda S flat, KNX based in this case. So ideal, equipped with permanent light metering. The lux levels could be adjusted from externally. And finally, we have here short-term presence inside. So for instance, as well, just as an example, so when somebody is entering as a teacher, as a perspective from a teacher, for instance, just entering in this classroom, okay, nobody there, okay, go, done. So our sensors are smart enough to realize, okay, there was just a person there, just watching in. So we take this time frame, and if the time frame is below 20 seconds, so the set delay time, which is in general in the classroom or however 10 to 15 minutes, so is automatically readjusted to down to 2 minutes. Latest after 2 minutes, the light control, the automatic light control is switched off. And as well, and this could be of interest as well, depends on if you equip, for instance, a schoolroom or industrial area, however, so you can, for instance, adjust the speed setting. So that means the constant light control, how fast or how slow it should act. I recommend to keep this in a middle or in a low, let's say, speed quality, because if you are a little bit sensitive and probably you are, affected by a migraine or so, so then a fast constant light control is not to be recommended. So in this case, keep it in medium or in slow, let's say, speed. But what is most important, for instance, if you have chosen, for instance, these school settings here, anytime if you override, so you can momentarily, you can put the light or set the light to your desired value. So like I mentioned, for instance, the teacher, for instance, wants to show video or whatnot, and artificial light is probably a little bit, hinderly, it's too bright. However, anytime you can override temporarily, this is one option. And if you put these settings in our presence sensor into office position, so if you modify brighter or darker, for instance, so then this new value is the set value from which the constant light control, or on which the constant light control is controlling on. So that means you want to have more light, so you dim reasonable a little bit more up. So then it's the new threshold, and the constant light control is controlling, especially to achieve this new set threshold. When all the parties have left the room, again, the delay time has elapsed. So then in both cases, so school or offices, so then back to normal. So that means the set values in the ETS settings are taken when the next person or the next person enters, or when the next lesson, for instance, starts. So that means presence dependent control, smart and clever, energy efficiency, automatical and full automatical heating and cooling support, sun tracking at its best, maximum of CO2 air quality, energy optimized, and fast and easy to configure. So that's the theory. So we put all these ideas together in one room and in one solution in order finally to get, we name it, the clever room. So now we move to the ETS, and you discover here different, let's say, group addresses which we have prepared. So we need, for instance, to set, and I do it online now, I have just to do a cross check if I'm linked with the IP router. Give me just a second to be on the safe side. Okay. I have to link to. Came back to this, yeah, company settings. Sorry for keep you waiting for this second, but I have to change now the link to the Wi-Fi network to the router, which is inbuilt here in my demo case. This takes a second. It's not me. It's just the system. Okay, here we are. So what we need finally, you see here, you discover here, we need date and time. For which purpose? Probably you remember, hopefully you remember that the weather station, the meteor data, requires finally the date, yeah, in order to know if it is March, April, June. So that means this affects finally the sled's position. So that means the sun position can just be calculated if we know the date. As well, the system needs to know finally, so which current time we do have. So early morning, noontime, afternoon, however, this affects finally the sled's position. And for my demonstration, I will override here these communication objects manually. This is linked to the weather station, but just in order to read the values if required. What we did, we have here the outdoor brightness for our demo. In general, you need to know this weather station here is equipped with external sensors. So, but for this demo to be absolute safe, we are here in a small, let's say, studio, and to be on the safe side, that we have really the brightness that the system starts running. So we override here the external value. So that means this sensor is deactivated, and via the bus monitor assign a reasonable, let's say, value for this demonstration. Then presence is definitively given here from the presence sensor, which is starting later on the daylight control and which is discovering if somebody is in or out. However, then we need finally, this is a communication here for the dimming, for instance, for the constant light control. So we have here the TEPREMA, the sensor, presence sensor, giving us a switch command, sharing the switch command either here with the dimmer, DME 2T, or this is just a parallel solution, or you link it to the dolly gateway. Then you discover here, for instance, brighter, darker, same stuff. We have here the TEPREMA giving you the commands dimming up or dimming down. This dimmer requires finally the brighter, darker command. And again, for the DALI gateway, if you intend to operate or to control the DALI gateway or the lights which are affiliated to the DALI gateway, then you have to link here as well to the DALI gateway. Then we have the dimming value. This is required as well in order to keep this constant light control alive. This communication has to be permanently existing. So that means the presence sensor sends the value to the dimmer or to the DALI gateway. And then we need the dimming feedback. So this is as well essentially for the daylight control, coming from the sensor and the communication to the dimmer or to the DALI gateway. Then we need sun control on off. So that means, for instance, this is as well essentially, but there are two steps how you can do it. Either with the IO command. So that means you have, for instance, a time control, time switch, or from visualization, microserver, however, you have a time system telling the system, so early morning at earliest, for instance, 7 o'clock, this control, this automatism can start. And during the afternoon or in the afternoon, for instance, 6 p.m. or so, there is no lesson. There is probably the office is closed. However, so then we can stop this automatism. However, so this I will override manually as well. So then we need blinds up, down. Sure, comes finally from the metadata. Yeah, so the metadata decides finally according to the brightness situation discovered basically from the weather station, sends the up-down command to the shutters and blinds actuator. In our case, this is the small appliance which is here inbuilt. Later on, we will switch to the camera and you will see the things accordingly. And this is just here to operate manually or to override manually the control command up and down. The step stop just comes from the display, from the room temperature controller with the display and with the ability to additionally to let's say to move blinds or however. Here we need just the step stop. Weather station does not need to send a step stop command because the weather station sends finally, now I do one step further, the weather station sends a percentage value in order to adjust the sled's position accordingly. And the weather station as well sends the height on which position finally the sleds shall run to. This one we have just set because as well for this demonstration in our studio to keep this system under control, to show you how it works finally. So we are giving the system external temperature. So that means I later on send a temperature command to the system, and so we have it under control. Because if we leave it into this, let's say, demonstration in this inbuilt room temperature control, you never know how the temperature is rising or lowering, and to keep this under stable conditions, so we override it currently. The current actuating room temperature is required. This is something which is essentially because this actual value coming from the room temperature controller has to be linked as well to our shutters and blinds actuator, because if the shutters and blinds actuator wants to give you the reasonable support, he needs to know how the condition is, how the condition is inside in the room and how's the situation outside in the situation outside, for instance. So that's almost all what we need. Then we need, for instance, the air quality control. So that means this manual override to IO to modify it accordingly. And for instance, you can link this CO2 value, because the CO2 value is linked to the system. So here the FCA2, for instance, is giving you a percentage value, for instance, to drive a dumper or to drive, for instance, the reasonable fan steps. We did, let's say, the dehumidifying in a different way in this example. So for instance, the dehumidifying we did as well. we take this CO2 value and we give it to one of our switching actuators, and our switching actuators are equipped with the so-called threshold switching. So with this percentage value which we have here from the Amun coming, which is coming from the Amun, we take this into the threshold settings, and in the threshold settings of the switching actuator, we decide if the step 1, for instance, shall start or not. That's the reason why we get here a switch as an output, a switch command or not. So that's it. So back coming to our move up here. Okay, and again, so it's a little bit slow here. So here we are. So we have here now time. Let's start a short example. So I send here write a value. So assuming, for instance, we start 7 o'clock and 15 minutes. Okay. And write this. Okay, why occurred? What's ongoing here? That's again. So, and write the value. So I see. I will do probably the commissioning. Give me just a second. It switches obviously always back to the page which I don't want to have. And I discover now a pretty slow communication in my system. Currently, I have just a white sheet of paper. This is something which I does not like currently. Okay. So I go here to, I try to switch to the other page. Currently, the ETS gets stuck. I just get a white sheet of paper now. This is. Bitte? Yeah, yeah, but I cannot see. So there is something in the background, and there is some in the background now. This is, I'm really sorry for that. What happens now? No. White screen, don't know why. Yeah, habe ich komme dran. So, don't know why. So I'm really sorry what happens now. I wanted to start now exactly that presentation here. But what you see is what I get finally, unfortunately. Obviously the ETS gets stuck and probably go down to just one just one presentation. Probably it is based on Windows or based on So okay, we need to restart ETS. Obviously the ETS gets stuck. Sorry for that. I'm really sorry, but it's not my fault. So there you see, gone. Scheiße. So, da ist eine ganze Menge verloren. Die sind alle schön Standby jetzt. So sorry, guys. You see, I have to restart the ETS, and this takes time. And you see, it's not my fault. It's not myself because the system is so slow. It's my laptop and the ETS, which yeah, troubles me currently. So I try to open the topology. Okay, now it seems to be okay again. Comes. So let's just see what happens here. If I'm online. Okay, I'm online. Okay, again. So then I open the workspace and the group addresses and full screen. So looking forward to that. We do have now immediately again our pages which we need. So let's see, smart room. So again, hopefully I can have this now. 3, 2, 1. Okay. So again, try to write the value. So I'm now 07. So okay, send date and write value. So assuming, for instance, we are talking about March. It's okay. So then we need to send the base set temperature. So external brightness. We need room brightness external value. So need this here, outer brightness, this one here. We need to control, right? And assuming we have, for instance, 20,000 lux, it's okay, but nothing happened again. So you see here on the presentation, probably, Christoph, you can start the camera link. So presence currently is not existing. We need the sun control to activate. Sun control activating here. I write the value, for instance, it's true. So this is fine so far. And we need the room temperature, actual room temperature, and this we need to write as well. So the current room temperature is, for instance, 18 degrees. And send. And we need, so what happens currently? So nothing, because it is early morning. We have 20,000 lux to get a better overview. So we see here it is 7:10. So then we have the 1st of March. 20,000 lux is external brightness. Sun control is activated, and the current room temperature is 18 degrees. So nothing happens. So that means the blinds remain open, what you can see here. So now probably the class is occupied, okay? So that means we have here no need to do any kind of shading because the sun is such flat. And what I'm doing now is here, I'm giving here the right value, and I write here, for instance, 808. So, and what you see now, so the blinds are, or the blind in this case, is moving down, and we concentrate here on this value here. So that means the current value is finally in this stage. Slats is on 15% about, yes. So and now I modify the time, write the value to, for instance, 10 o'clock. So and you see the correction of the slats is done. So the slats have opened a few bit more, and further on I do another, download another time, and now you see the slats are in a horizontal position and the light condition is currently not met because it's too bright in our studio, and probably I can manipulate a little bit. So to give the sensor, let's say, the feeling it is dark enough, and so due to that, the light, the constant light control, for instance, has to start accordingly. What you discover here, so the condition currently, constant light starts, and the heating and cooling control is currently ongoing. And if nobody is in the room anymore, so after a short while, so the room, the presence should turn to not occupied, and then the blinds shall open again, because the thing is finally that it takes a while and so then the blinds are moving up again to their upper position. Depends on how it is finally controlled. If I give here, for instance, a little bit of humid, so then, for instance, it takes a few seconds, and that means that the you see now it turns to another color, and the thing is finally so that now the stages here in the actuator are meanwhile stage two to dehumidify, for instance, and that means that we, for instance, have now the dehumidifying, the maximum of dehumidifying, and so that means here we have let's say a good air control for that purpose in the room, the dehumidifying. The blinds are up meanwhile, and the condition is met. What if, for instance, if we have here the shading control, I just move it in a specific position now, give a stop command, and what if during this, let's say, automatism, we have here, let's say, a heavy wind, and so you see the blinds are running up. So, and then finally, I think it's it's easy for you to assume that the cooling support is working accordingly. So depends on the temperature. So you run to a specific position. And when the blinds are running down now, so I have positioned it manually to that position. If the condition is not met anymore, so the wind speed is too low, too slow, so then the blinds are running to their former position, however. So finally, this is more or less, this is the webinar's end. So for today, so hopefully I could give you some reasonable good impacts.
Unmuted.
And inputs finally. I have to say sorry for this short trouble with the ETS, which we had finally discovered. Sorry for that. But at the end, finally, you could see it works, the system, and the way how to do the group addressing and the setup is really, really simple. It's not really specific. And if you like, so anytime, please come back on us. If you like to have, for instance, the recording, so we will prepare. We have now to convert it, and I would assume tomorrow or day after tomorrow, the tutorial or this video recording is available. And if you want to have the presentation or the export of the group addresses, so come back on Paul, for instance, or come back to us in Germany, and we highly appreciate to share this with you. At the end, finally, I have to say thank you for your time you shared with us. And if it was probably and hopefully interesting for you, you have discovered at the earliest beginning, so that we have scheduled some more webinars in the really soon the future. So, and if you want to participate, always welcome. We will be really happy to welcome you again. Bye-bye.
Thank you, Elmar.
My pleasure.
Can I just, before we close off, I'd like to thank Elmar and Christoph for doing the presentation. There's a couple of things, and just to reiterate, if anyone wants the video and stuff, that will be available. So get in touch with myself or with the team directly, but it's fine to go via me. That's great. It was interesting. Can I just, as a couple of a question that I want to bring up, talking about the CO2 levels. We're talking about like schools and in offices. There's also a requirement for CO2 monitoring in passive house buildings as well, where they're not so much looking at the heating requirement, because there's obviously not a heating element within the building, but that monitoring, that level of monitoring the CO2 is really important in that particular instance. So the presence and the CO2 monitoring then becomes really critical, because they're talking about a building that it's only going to sort of move 1 or 2 degrees. So once you start bringing in CO2 monitoring and solar gain as well, this sort of thing is ideal, isn't it? So it has that application as well.
How the application is, you have basically the CO2 becomes, not becomes, is it's present now. It is state of the art in such kind of sophisticated buildings. Even in some, let's say, more comfortable single family homes, we have meanwhile equipped CO2 sensors, because there is a reasonable demand for such. Yeah. So for instance, you have a passive house, and the passive house finally cares about, let's say, the ideal, let's say, room temperature, the climate inside. But what if you are, for instance, in the office? Is there any need, any requirement to do the air exchange? Yeah. If you do it just by a time frame or by a time calendar, however, so it doesn't make really sense, because if nobody is at home in your private flat, so why we should have the air exchange? Why we blow warm air, especially in the winter times or the winter seasons, why we shall blow out warm air, which is costly, gas or oil or electrical heat, however, yeah, why should it blow out when there is no need? Because nobody there, the CO2 level should not be increasing, it should be stable. And just in the event of somebody comes home, your wife, your children, yourself, however, and then the CO2 value will rise slowly and steadily. And then the CO2 level, CO2 sensor is finally the independent referee, deciding finally, let's say referee, so deciding finally if this air exchange system, this really high efficient air exchange system, shall start or shall be started, however. It's okay for you, the answer?
Yeah, absolutely. Yeah. And it's as well, that sort of what you're talking about there, about that room by room control and looking at those various levels. And it comes through as well on the with the ETS. Planning on something like this is really important. It's not something where you're just going to throw all the actuators into the consumer unit, into the distribution board, and sort of do it on the fly. This is something that you need to plan. You need to work out. You need to speak with your customer. You need to really know your building. So this is something that I think for the integrators and the installers and for the sales guys as well, is to really appreciate what it is capable of, and then be able to get that over to the customer. So yeah, planning is everything.
Sure, right. At the beginning, you know.
Yes.
You do it right at the beginning, so then the result finally is reasonable.
Yeah.
And if you do some mistakes in the planning status finally, so then don't expect too much in the result at the end.
Yeah.
You know.
Yeah, absolutely. Well, thank you very much, Elmar, for that. Thank you very much, Christoph. I'm going to let everyone go. I'd like to thank once again MyKNXStore for facilitating this presentation and supporting us on this one. And if you've got any questions, don't hesitate to ask. So thanks very much, team. Thank you.
Regards to UK. Bye.
Thank you.